Class Loader explained step by step. Introduction. A class loader is a part of the JVM that loads Java classes into memory. When you write Java code, public class main, public static void main string args, user service, new user service. The JVM cannot use main or user service until those classes are loaded. That job is done by class loader. Simple flow. Java class file, class loader, JVM memory, program runs simple definition. Class loader means a JVM component that loads .class files into memory when they are needed. Example: userservice.java, java userservice.class, class loader loaded into JVM. The class loader loads class files, Java library classes, application classes, third-party dependency classes, framework classes. Why class loader matters. Class loader knowledge helps with JVM architecture, Java interview preparation, Spring Boot startup understanding, dependency issues, ClassNotFoundException, NoClassDefFoundError, classpath debugging, plugin systems, application servers, custom class loading, memory leak debugging. For backend developers, class loader is important because every Java and Spring Boot application depends on class loading. Big picture Java source code, Java compiler, .class bytecode, class loader, JVM runtime memory, execution engine, program runs. Class loader is the bridge between .class files on disk and classes available inside JVM memory, class loader in JVM architecture, plus derop, class loader and JVM, plus class loader subsystem, and loading, linking, and initialization, plus runtime data areas, heap, 1s, stack, 1, Metaspace, plus, its execution engine, plus. Important concept. Class loader does not load all classes at once. It usually loads classes when they are first needed. This is called dynamic class loading. Example: public class main, public static void main string args, system output line start. User service equals new user service. User service may be loaded when JVM first needs it. Class loading process. Class loading has three major phases. 1. Loading. 2. Linking. 3. Initialization. Linking has three substeps. 1. Verification. 2. Preparation. 3. Resolution. Full flow. Loading, linking, verification, preparation, resolution. Initialization step 1. Loading means JVM finds the .class file and loads its bytecode into memory. Example: main.class, userservice.class, product.class, string.class, ArrayList.class. During loading, JVM creates an internal representation of the class. Simple idea: find class file, read bytecode, create class metadata, store class information in Metaspace. Loading example: Java code, public class main, public static void main, string args, product is new product. Before running, main.class exists, product class exists. When JVM starts, class loader loads main.class. When product is used, class loader loads product.class. Step 2. Linking. Linking prepares the loaded class for execution. Linking has verification, preparation, resolution. Step 2.1. Verification. Verification checks if bytecode is valid and safe. JVM checks: is the bytecode format correct? Are types used correctly? Are stack operations valid? Does the code follow JVM rules? Is the class file safe to execute? Why this matters. Bad bytecode should not crash or corrupt the JVM. Simple explanation. Verification protects JVM from invalid class files. Verification example. If bytecode says, treat integer as object reference, or jump to invalid instruction, JVM verification should reject it. This is one reason Java is considered safer than directly running unchecked native code. Step 2.2. Preparation. Preparation allocates memory for static variables and sets default values. Example. Public class appConfig. Static int count equals 10. Static string appName equals demo. During preparation, count equals 0, appName equals null. Not actual values yet. Actual values are assigned during initialization. Preparation default values. Type default value int 0, long 0l, boolean false, double 0.0, object reference null. Example. Static int count equals 10. Preparation. Count equals 0. Initialization. Count equals 10. Step 2.3. Resolution. Resolution converts symbolic references into direct references. Example. System.out.println hello. The bytecode may contain symbolic references like Java lang system out println Java lang string. During resolution, JVM connects those names to actual classes, fields, and methods. Simple idea. Symbolic name means actual runtime reference. Step 3. Initialization. Initialization assigns actual static values and runs static blocks. Example. Public class appConfig. Static int count equals 10. Static system.out.println static block running. End. During initialization, count becomes 10, static block runs. Output. Static block running initialization example. Public class main, public static void main, system.out.println, appconfig.count, class, appconfig. Static int count equals 10. Static system out println appconfig initialized. Output. Appconfig initialized 10. Why? Appconfig is initialized before accessing static variable count. Class loading full summary. 1. Loading. Find .class file. Read bytecode. Create class metadata. 2. Linking. Verify bytecode. Prepare static variables with default values. Resolve symbolic references. 3. Initialization. Assign actual static values. Run static blocks class loader types. Common JVM class loaders. 1. Bootstrap Class Loader. 2. Platform Class Loader. 3. Application Class Loader. Older Java explanations often mention Extension Class Loader. In modern Java, this is generally replaced by Platform Class Loader 1. Bootstrap Class Loader. Bootstrap Class Loader loads core Java classes. Examples. Java lang string, Java lang object, Java lang system, Java util list, Java util hashmap. Simple idea. Bootstrap loads the most fundamental Java classes. Important. Bootstrap Class Loader is not written as a normal Java object like your application class loader. It is part of the JVM implementation. 2. Platform Class Loader. Platform Class Loader loads platform-level Java classes. It loads classes from Java platform modules and libraries. Simple idea. Platform Class Loader loads Java platform classes that are not loaded by Bootstrap. 3. Application Class Loader. Application Class Loader loads your application classes. Examples. com.example.main, com.example.userService, com.example.productController. It also loads classes from your application class path. Example. Target classes application jar, dependency jars. Simple idea. Application Class Loader loads your code and your dependencies. Class Loader hierarchy. Bootstrap Class Loader, up. Platform Class Loader, up. Application Class Loader. When your app needs a class, the request usually starts from the application class loader. But because of delegation, it asks parent class loaders first. Parent delegation model. Parent delegation means before a class loader loads a class, it asks its parent first. Flow. Application class loader asks parent platform class loader, asks parent bootstrap class loader. If parent can load the class, parent loads it. If parent cannot load it, child tries to load it. Parent delegation diagram. Need class java.lang string. Application class loader asks platform class loader asks bootstrap class loader loads java.lang.string. For your own class, need class com.example.userService. Application class loader down asks platform class loader asks bootstrap cannot find it. Platform cannot find it. Application loads user service. Why parent delegation matters. Parent delegation helps with security, consistency, preventing duplicate core classes, protecting Java core libraries. Example: suppose someone creates package java.lang public class string. The JVM should not use this fake string class instead of Java's real java.lang string. Parent delegation helps prevent that. Class loader example in Java. You can check the class loader. Public class loader example. Public static void main string eggs system.out.println string.class.get class loader system.out.println class loader example.class.get class loader. Possible output concept. Null jdk.internal.loader.classloaders $app class loader. Why string.class.get class loader may print null. Because string is loaded by Bootstrap Class Loader. Bootstrap Class Loader is represented as null in Java API. Your class is loaded by application class loader, and Metaspace. When class is loaded, class metadata is stored in Metaspace. Example: public class product, private long ID, private string name. Metaspace stores class name, fields, methods, constructors, annotations, constant pool data. Important: class metadata means Metaspace. Object instances means heap. Method calls means stack. Class loader and object creation. Class loading is different from object creation. Example: product equals new product. Before object creation, product class must be loaded. Then, product object is created in heap. Flow: product.class loaded. Product metadata stored in Metaspace. New product object created in heap. Class loading versus object creation concept, meaning memory. Class loading, load class metadata into Metaspace. Object creation, create object instance in heap. Method call, execute method in stack frame. Example: user equals new user. User class metadata means Metaspace. User object means heap. User reference means stack. When does class initialization happen? A class is initialized when it is actively used. Common triggers: creating an object with new, accessing static variable, calling static method, using reflection, initializing subclass, may initialize parent first. Example: app config print. Calling a static method can initialize app config. Static initialization order. Example: class parent. Static system.out.println parent static block. Class child extends parent. Static system out println child static block. Public class main, public static void main, string args, new child. Output: parent static block, child static block. Why? Parent class initializes before child class. Important example: static variable initialization. Public class test. Static int value equals 10. Static value equals 20. public static void main string args. System out println test value output 20. Y. During preparation, value equals 0. During initialization, value equals 10. Static block changes value to 20. Class not found exception. Class not found exception means JVM tried to load a class by name but could not find it. Common causes: missing jar, wrong class path dependency, not included, wrong class name, driver class missing, reflection loading failed. Example: class.forName com.mysql.cj.jdbc driver. If MySQL driver jar is missing. Class not found exception. Class not found exception. Example: public class main, public static void main, string args, throws exception. Class.forName com.example does not exist. If class does not exist, java.lang.classNotFoundException com.example.does not exist. Fix: check dependency, check jar, check package name, check class path, check spelling, NoClassDefFoundError. NoClassDefFoundError means class was available during compilation but missing at runtime. Common causes: jar exists in compile time but missing in runtime deployment package, missing dependency, wrong server class path dependency conflict, removed class version mismatch. Example: code compiled successfully, but running app fails because dependency jar is missing. Class not found exception versus NoClassDefFoundError. Error meaning class not found exception, class not found when explicitly trying to load it. NoClassDefFoundError, class existed at compile time but missing at runtime. Simple difference: class not found exception means usually dynamic loading reflection class path lookup. NoClassDefFoundError means runtime missing dependency after successful compile. Linkage error means class was found, but there is a problem linking it. Common causes: incompatible library versions, method signature mismatch, duplicate jars, class version conflict, binary incompatibility. Example: your code expects method A. Runtime jar has older version without method A. Possible error: no such method error. This is a type of linkage problem. Unsupported class version error. This happens when class was compiled with a newer Java version, but running on older Java version. Example: compiled with Java 21, running with Java 17. Possible error: unsupported class version error. Fix: use correct Java runtime version or compile with compatible target version Class Loader in Spring Boot. Spring Boot uses class loading heavily. When Spring Boot starts, JVM starts, main class loads, Spring application.run, Spring loads framework classes, application classes are scanned, controller, service, repository classes loaded, beams are created, application starts. Example: at Spring Boot application public class product application, public static void main, string args, Spring application.run, product application.class. Classes loaded: product application, product controller, product service, product repository, Spring framework classes, database driver classes, Jackson classes, Tomcat Netty classes, Spring bean creation versus class loading. Class loading: JVM loads product service.class metadata. Bean creation: Spring creates product service object. Memory: product service class metadata means Metaspace, product service bean object means heap. Important. Class loading is JVM level. Bean creation is Spring level. Class loader and JDBC drivers. When using JDBC, database drivers are loaded as classes. Example: PostgreSQL driver, MySQL driver, Oracle driver, SQL Server driver. If driver dependency is missing, you may see class not found exception, no suitable driver found. Fix: add correct JDBC driver dependency. Check runtime class path. Restart application, class loader and Maven dependencies. Maven downloads dependencies into your build. Example: dependency, group ID, org PostgreSQL group ID, artifact ID, PostgreSQL artifact ID, version 42XX, version. At runtime, that jar must be available to the application class loader. If dependency is not included, class not found, class loader and fat jar. Spring Boot often builds a fat jar. Fat jar means application classes plus dependency jars. Command: Java -jar app.jar. Spring Boot has its own launcher mechanism to load nested jars. Simple idea. Spring Boot package jar includes your app and dependencies. Class loader loads classes from inside the jar. Custom class loader. A custom class loader is a class loader you create by extending class loader, used for advanced cases. Plugin systems, application servers, dynamic modules, scripting engines, isolated class loading, hot deployment. Most beginners do not need to write custom class loaders, but you should understand the concept. Simple custom class loader idea. Default class loader loads classes from classpath. Custom class loader can load classes from custom location. Examples: load class from database, load class from network, load plugin jar, load encrypted class file. Again, this is advanced for most backend developers. Understanding default class loading is enough. Class loader memory leaks. Class loader leaks can happen when old class loaders cannot be garbage collected. Common in application servers, hot deployments, plugin systems, dynamic class generation, repeated redeployments. Possible causes: static references, thread local references, running threads, JDBC drivers, not deregistered, cached class references. Result: Metaspace memory keeps growing. Possible error: out-of-memory error, Metaspace debugging class loading issues. Check. 1. Is the class present in dependency? 2. Is the jar available at runtime? 3. Is package name correct? 4. Is Java version compatible? 5. Are there duplicate versions of same library? 6. Is Maven Gradle dependency scope correct? 7. Is the app packaged correctly? 8. Is the server using old jar? 9. Is classpath correct? 10. Is Spring Boot fat jar built correctly? Useful commands: check Java version, Java-version. Check compiler version, Java-version. Inspect jar contents, jar tf app jar. Search for class in jar, jar tf app jar grep user service. Maven dependency tree, MVN dependency tree. Gradle dependencies, .gradlo dependencies. Debugging example: missing PostgreSQL driver. Error: java.lang ClassNotFoundException. org.postgresql.driver. Cause: PostgreSQL driver dependency missing at runtime. Fix: 1. Add PostgreSQL dependency. 2. Rebuild application. 3. Check package jar. 4. Restart app. Maven dependency. Dependency: group ID, org PostgreSQL, group ID, PostgreSQL, artifact ID. Dependency. Debugging example: Java version mismatch. Error concept: unsupported class version error. Cause: class compiled with newer Java version than runtime supports. Example: compiled using Java 21, running using Java 17. Fix: 1. Run app with Java 21, or 2. Compile app targeting Java 17. Debugging example: duplicate library versions. Problem: application starts but fails with no such method error. Possible cause: compile time library version and runtime library version are different. Fix: 1. Run MVN dependency tree. 2. Find duplicate conflicting versions. 3. Exclude old dependency. 4. Force correct version. 5. Rebuild and redeploy. Class loader debug flag. You can ask JVM to print class loading information. For modern Java, Java -xlog class load -jar app.jar. This can show classes being loaded. Use carefully because output can be very large. Common beginner mistakes. 1. Thinking class loading creates objects. Wrong. Class loaded means object is created. Correct. Class loading creates class metadata. New keyword creates object. Example. User equals new user. User class metadata means Metaspace. User object means heap2. Confusing compile time and runtime. Compile time. Java checks and creates .class files. Runtime. JVM loads and executes classes. A class can be present at compile time but missing at runtime. That can cause NoClassDefFoundError. 3. Ignoring dependency scope. In Maven, dependency scope matters. Examples. Compile, runtime, provided test. If dependency is test, it may not be available in production runtime. If dependency is provided, server must provide it. 4. Assuming HashMap object classes are loaded by your app loader. Core Java classes are usually loaded by Bootstrap Class Loader. Your application classes are loaded by Application Class Loader. 5. Thinking hash set order issue is class loader issue. Sometimes developers blame class loading for unrelated behavior. Example. Hash set output order changed. That is not class loader issue. That is because hash set does not guarantee order. 6. Not checking Java version. Always check Java-version, Java-version. A common issue is IDE uses Java 21, server uses Java 17, best practices. Cut. Understand loading, linking initialization. No parent delegation model. No Bootstrap, platform, application class loaders. No class metadata goes to Metaspace. No objects go to heap. No class loading is not object creation. Check classpath when class is missing. Check Maven Gradle dependency tree. Avoid duplicate dependency versions. Use correct Java runtime version. Understand Spring Boot FATJAR loading conceptually. Investigate ClassNotFoundException and NoClassDefFoundError differently. Be careful with static references in app servers plugins. Use class loading logs only when needed. Class loader interview questions. 1. What is class loader? Class loader is a JVM component that loads .class files into memory. 2. What are the phases of class loading? Loading, linking, initialization. Linking includes verification, preparation, resolution. 3. What happens during loading? JVM finds the class file, reads bytecode, and creates class metadata. 4. What happens during verification? JVM checks if bytecode is valid and safe. 5. What happens during preparation? Static variables are allocated and assigned default values. 6. What happens during resolution? Symbolic references are converted into actual runtime references. 7. What happens during initialization? Actual static values are assigned and static blocks run. 8. What are common class loaders? Bootstrap Class Loader, Platform Class Loader, Application Class Loader. 9. What does Bootstrap Class Loader load? Core Java classes like java.lang.string, java.lang.object, java.lang.system. 10. What does Application Class Loader load? Your application classes and classes from Application ClassPath. 11. What is parent delegation? Before loading a class loader asks its parent to load it first. 12. Why is parent delegation important? It improves security and avoids duplicate loading of core Java classes. 13. Where is class metadata stored? Class metadata is stored in Metaspace. 14. Is class loading same as object creation? No. Class loading loads class metadata. Object creation creates an object in heap. 15. Difference between ClassNotFoundException and NoClassDefFoundError. ClassNotFoundException usually happens when code explicitly tries to load a class that is not found. NoClassDefFoundError usually happens when a class was available at compile time but missing at runtime. 16. What is unsupported class version error? It happens when class was compiled with a newer Java version than the runtime supports. 17. How do you debug class loading issues? Check. Class path dependency tree, jar contents, Java version, dependency scope, duplicate versions, packaging server runtime, class loader roadmap, beginner level. Learn. What is .class file? What class loader does? Loading, linking, initialization. Bootstrap platform application loaders. Parent delegation. Practice. Compile Java file. Run Java file. Print class loader of string and your class. Intermediate level. Learn. Class, path, dependency jars, Maven dependency scopes, ClassNotFoundException, NoClassDefFoundError, Spring Boot class loading. Practice. Inspect jar contents. Run MVN dependency tree. Understand missing dependency errors. Advanced level. Custom class loaders, plugin loading, class loader leaks, Metaspace issues, application server redeployment. Practice. Use xlog class load. Analyze duplicate library version issue. Understand Metaspace leak conceptually. 30-day learning plan week 1, basics. Learn. Check .java to .class. Check. JVM starts. Check. Class loader role. Check. Loading, linking, initialization. Practice. Create main.java. Compile with Javac, run with Java. Explain when main class is loaded. Week 2, class loader hierarchy. Learn. Check. Bootstrap Class Loader. Check. Platform Class Loader. Check. Application Class Loader. Parent delegation. Practice. Print class loaders for string, array list, and your own class. Week 3, errors and debugging. Learn. ClassNotFoundException. NoClassDefFoundError. Unsupported class version error. No such method error. Class path. Dependency tree. Practice. Use MVN dependency tree. Inspect jar contents with jar TF. Check Java version mismatch. Week 4. Spring Boot and production. Learn. Click. Spring Boot fat jar. Dependency packaging. Application class loading. Metaspace. Class loader leaks basics. Class loading logs. Practice. Build Spring Boot jar. Run Java-jar. Understand how app classes and dependency classes are loaded. Real-world backend scenario. Spring Boot app fails on server. Error. Java.lang.NoClassDefFoundError. COM example, payment client. Local app works. Server fails. Possible causes. Jar missing on server. Dependency not packaged. Wrong deployment artifact. Old version deployed. Runtime class path different from local. Debug steps. 1. Confirm local and server artifact are same. 2. Inspect jar contents. 3. Check Maven Gradle dependency. 4. Check dependency scope. 5. Rebuild clean. 6. Redeploy correct artifact. 7. Restart app. Real-world backend scenario. JDBC driver missing. Error. Class not found exception. org.postgresql.driver. Cause. PostgreSQL driver not available to application class loader. Fix. Add PostgreSQL dependency. Rebuild application. Confirm driver jar is included. Run app again. Final summary. Class loader is a key part of JVM architecture. Important concepts. Class loader loads .class files. Class loading has loading, linking, initialization. Linking has verification, preparation, resolution. Static variables get default values first. Static blocks run during initialization. Bootstrap loads core Java classes. Platform loads platform classes. Application loads your classes. Parent delegation asks parent first. Class metadata is stored in Metaspace. Object instances are stored in heap. Class loading is not object creation. Key idea. Class Loader loads class definitions into JVM memory, so the program can run. For interviews, explain this flow. .class file means loading, means linking, means initialization, means Metaspace, means execution. For debugging, remember, ClassNotFoundException means class not found during explicit loading. NoClassDefFoundError means class missing at runtime after compile. UnsupportedClassVersionError means Java version mismatch.